Okay, DJ, little heads up. This week is going to be a bitch. We're going to get into, excuse me, differential equations, man. So, here's our first video of the week. So, we're just doing number 2. So, what do? Well, they gave us the derivative, right? Remember, dy dx is really y prime, okay? So, they gave us the first derivative, and to find its equilibrium values, what they mean by that is when does its rate of change become 0? So we basically set it equal to 0, simple enough. So we got these two values, -2 and 3. The next thing is we need to figure out whether each of them are stable or unstable. And then we're going to construct the phase line and identify what y prime and double prime is doing. And then we're supposed to sketch several solution curves, which is going to be kind of guessing, but I think we'll do a decent job on it. So here's the deal. I already did a lot of the legwork here. So we came up with -2 and 3, right? And so now what we need to do is we need to, for example, figure out what it's doing in the 3 sections here. So since we have 2 solutions, we know there's left, there's middle, and there's right of those values, right? These are our equilibrium values. So what we do is, since this one's -2, we put in a number, let's say like -3. Well, -3 plus 2 is -1. -3 minus 3 is -6. And a negative times a negative is a positive. So we know that y prime is positive. It's greater than 0. Okay? Now, let's plug in a number between -2 and 3, like 0. So when I plug in 0, now here's the shortcut. I'm going to plug in 0. I know that 0 plus 2 is a positive. I know that 0 minus 3 is a negative. A positive times a negative means y prime is less than 0. It's negative. Now, a clever person, of course, will realize that it should go positive. It will always alternate negative, and then it should be positive. But just to make sure, we're going to plug in the number 4, which is to the right of 3. 4 plus 2, 4 minus 3, right? Well, 4 plus 2 is a positive 6. 4 minus 3 is a positive 1. And, of course, we just proved that it's going to be positive. So now what? Well, we got to take the second derivative. That means we take the derivative of y prime. And so what we're going to do here is we're going to actually times our derivative together. And using the FOIL method, we're going to get y squared minus y minus 6. Now let's take the derivative of that. Well, the derivative of y squared is 2y. dy dx is really just y prime. Minus... and the derivative of minus y would be minus 1 y prime. And of course, the derivative of -6 is 0. So notice we can factor out 2y minus 1. So 2y minus 1 times our y prime. Wait a minute, what was our y prime again? Our y prime was this. So the double derivative is 2y minus y. Our y prime again is y plus 2, y minus 3, right? When does that equal 0? Well, we already know -2 and 3. We already got those taken care of, right? But this could also now equal 0. So what's 2y minus 1 equal to 0? 2y is 1. That means y is 1/2. Now what this is going to become, DJ, let me get rid of this excess of stuff. You actually hopefully saw it on the previous page right down here. Okay. But anyways, what I'm trying to get at is we got 2y equal to 1/2. This value, as we'll find out, is going to always be an inflection point. In other words, inflection point means, let's say it's curving this way. When it hits the inflection point, it starts curving the other way. Okay? So hopefully you kind of remember inflection points from calculus. All right, so now that we know those three values, we now are going to do it again. Now let's take some notes here, because I think, yeah, I left all those blanks to finish up this problem with. So the idea is we already know that the derivative goes positive, negative, positive. Okay, so the derivative y prime is positive, then negative, then positive again. Oops, I got in the wrong section. See, this whole section between -2 and 3 is going to be negative, and then over here it's going to be positive again. Now we're going to do the second derivative, and remember, a negative on a second derivative means a negative concave, and a positive second derivative means a positive concave. Woo! Okay, so we're going to use our shortcut here. So let's say I pick over here the value -3. I'm going to plug in -3. Well, let's just do some mental math here. -6 minus 1 means it's a negative. -3 plus 2 is a negative, right? Please, Lord, don't make me make a mistake. And -3 minus 3 is a negative. So 3 negatives means our y double prime here is actually negative. Now, we have, because of this 1/2, this is our inflection point, okay? We have to check both sides of that. So in here, how about we do -1 next? So let's say I do -1 instead. And this is where you're going to want to pause and take notes, TJ. But again, doing mental math, -2 minus 1 means it's negative still. -1 plus 2 means it's positive, right? Negative minus 3 means it's negative. So negative positive times a negative is positive. Now, just to save some time, we now know that the double prime is going to be positive, and that makes sense. See, it should alternate. Less than 0, greater than 0, double prime less than 0 in here, double prime greater than 0 here. Okay? So now what? Well, hopefully you pause or rewind the video if you need to, because I need the workspace here. So there's two things we got to answer now. One is, let's go back to just the derivative. Notice how greater than 0 means it's increasing to the right. The derivative being negative means it's decreasing, going towards the left. So see how on each side it's going towards -2? That means -2 is stable. Okay? But if you look at the 3, remember we had originally 2 points here, right? Where are we? We had these 2 points here where those are equilibrium values. Now we're trying to see if they're stable or unstable. Okay? Well, on 3 here, notice how the derivative, y double prime positive, means it's going to the right, away from 3. And then, remember, this whole section in the middle here, it's negative. So that means it's going to the left, away from 3. And see how it's going away from 3, both left and right of it. That means we know that 3, so -2 was stable. 3, though, however, is unstable. And now we come to the last question. By the way, these number lines, this one and this one, where is it? This one here, those are your phase lines. So if you want to see what we did, we found our equilibrium values. We figured out whether they were stable or unstable. We constructed our phase lines for y prime and y double prime. Now we need to sketch some solution curves. Now this is going to be fun. This is some serious thinking here. So remember, this is with respect to y. So here's our x-axis, and our y-axis, there's our x-axis, right? And so we know if we're down here at -2, we know that this is basically an equilibrium. It's kind of like a, what you call an asymptote. And we know the other one's at +3. Okay? And we know 1/2 is right here somewhere, right? Just keep keep track of the 1/2, because here's the deal. We know if we go left of -2, which means below -2, remember? Because y, you're up and down. So less than -2 means below -2. We know that the slope is positive, meaning it's going up, but the concavity is negative. So what that means is it's going up sort of like this. Okay? That's what we know. Now, in between, remember the 1/2 now is going to be our inflection point here. Okay? So we might as well I'm just going to make a dot there. But we know that basically to the left, the slope is negative, meaning it's going down. This positive concavity means it's going down sort of like this, you see? It's going down, but it's in the process of curling up. But see, at the negative, it's now going to curl back down, like so. And it's going to approach both of our equilibrium values. Now, what about to the right of 3? Well, slope is positive, so we know our curves are going up. And y double prime is positive, so it's concave up. So we know it probably does something like this. Okay? So those are that's basically the best I can do, DJ. It's far from correct or perfect, but it's pretty close. All right? But anyways, I'm just going to stop the video there. As you can see, the other videos should go a little bit smoother than this one, but this is just one problem. Okay? And I did a decent job on every part of it. I'm pretty sure there is no answer key to go by, so we're flying blind.